Hello friends, how are you? Listen students, we in the last lecture studied some systems of measurement and there were FPS, CGS and MKS system. Okay, now for detailed studies of physics we require an international system which can be used in physics, technical purposes, scientific purposes, industrial purposes and commercial purposes. So friends, in 1971 there was a general conference on weights and measures in which a standard system of measurement was derived or was prepared for all the countries in the world. In fact, this system was internationally accepted. Its French name is Système Internationally the Unites, but we converted it into English as International System of Units. So the short form SI is the short form of French name and not English name. Système Internationally the Units. Okay, we will call it SI only, simply SI. Okay, now there are 7 fundamental physical quantities in this system, or we can say that only 7 physical quantities were considered to be fundamental or base physical quantities for this system. Okay, these fundamental quantities are, look at this. Base quantities, their units, base quantity, unit and symbol of unit. Okay, here are the physical quantities which we are going to use in our physics for next 2 years. Quantity number 1, that is length. Students, as you know, length is measured in meter, so the unit of length is meter and the symbol of this unit is small m. Okay, listen friends, length is a physical quantity. If we require to denote length by a symbol, then we will write only L, because L is the symbol of length. Length is the quantity and L is its symbol, but meter is a unit and m is its symbol. So if length is required to be written as a physical quantity, then we will write L only, and if we require to write its value, then the symbol of unit is m. Okay, for example, if we are asked to write the length of a room, then we will say that length of the room is L equals to 10 meter. This is the main difference between L and M. L is a symbol of physical quantity, while M is a symbol of a unit of that physical quantity. Okay, come on. Physical quantity number 2, mass. As you know, mass is measured in kilogram. The symbol is kg, small k, small g, both are small letters, kilogram. No point should be used there before k, after g, or between k and g. There is no point, no dash, no comma, nothing is there, only kg. Simply kg, both are small letters. Don't forget, these are the rules. Physical quantity number 3, time. Time is measured in second. Symbol small s. Small s is the symbol of second. Fourth, electric current. This is the fourth fundamental physical quantities. Fourth physical fundamental quantity, electric current. As you know what is current, you will discuss this current, electric current, in your 12th science. Okay, at present you need to learn name of a physical quantity only. It is electric current. It's measured in ampere. Ampere. Doesn't matter whether you write ampere in full or simply or shortly amp only. There is no change. But you have to remember, while you are writing a unit, then you can use only capital A. Only capital A as the unit. You can never write ampere in this manner. You can never write ampere in this way. You cannot write ampere as small a. You can't do this. Okay, capital A is the symbol of ampere. In fact, you can write small a here, no problem. Okay, now fifth physical quantity is thermodynamic temperature. Thermodynamic temperature. Fifth physical quantity, temperature, simply known as temperature. Its full name is thermodynamic temperature. You can call it temperature only, no problem. Temperature is measured in degree Celsius. Temperature is measured in Fahrenheit, degree Fahrenheit. Temperature is measured in Kelvin. So there are 3 units. But in this system, in SI, temperature is measured in Kelvin only. Okay, Kelvin, and its symbol is capital K. Okay, now physical quantity number 6, amount of substance. Amount of substance. Amount of substance. Substance means an object, anything. Its amount, value, is measured in a unit, mole, 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 and symbol of this unit is just MOL. It means remove E from the unit to get a symbol. Okay, so mole is the symbol of unit of amount of substance. Okay, now 7th fundamental quantity or base quantity is luminous intensity. Luminous intensity. Intensity means strength. Okay, luminous strength, or simply intensity of light, intensity of radiation. Okay, it's measured in candela, and denoted by CD, small CD. Right? So children, you have to remember these 7 physical quantities, in fact their names, their units and their symbols. Units are spoken only and symbols are written only. So in writing we require symbols, in speaking we require full name or units. If we have written kg, then it is spoken as kilogram. Okay, if you have written small s only, then it's spoken as second. Right? One more thing is, there are definitions given in the textbook. Definitions of all these units are given in the textbook, but they are only for your information. In fact, you can't understand at present the definitions of these units. They will be taught in your college. Okay? In fact, below the table in your textbook it is written that you need not remember or learn these definitions. Even board can't ask the definitions to write. Okay? So forget definitions. Just remember quantities, their units and symbol. So this was SI. In fact, this is SI. Now we can say that many other, in fact all other physical quantities can be derived by using suitable combinations of these 7 physical quantities. So all other or the remaining physical quantities are known as derived physical quantities. Only 7 quantities are base or fundamental, then the remaining all are called derived physical quantities. But there are 2 physical quantities. There are 2 physical quantities which are not fundamental, not derived, and these 2 physical quantities are known as supplementary physical quantities. Okay, so we have to understand two angles. Okay, these 2 angles are plane angle and solid angle. Okay, now dear friends, be careful, because these concepts of a plane angle and a solid angle are difficult up to some extent. So please be careful. In fact, supplementary physical quantities. Supplementary physical quantities are: number 1, plane angle. Symbol of this physical quantity is d theta. As you know, angle is denoted by the symbol theta. You have learned this in your 10th in trigonometry: sin theta, cos theta, tan theta. You studied this. Okay, but in this case, plane angle will be denoted by d theta if the angle is a small angle. If an angle is a small angle, then its symbol is denoted by d. Sorry, angle is denoted by d theta. Okay. Listen, here I have drawn an angle for you. This is a plane angle. Why? Because it can easily be drawn on a plane, on a surface, on a wall, on ground. The angle which can be drawn, which can be understood on a plane is called plane angle, or two-dimensional angle is called a plane angle. How can this angle be defined? For the definition, I would like to give you a technique. Take this point of intersection as center, and taking any radius you like, draw an arc. Okay? You have drawn an arc which is a part of a circle. This point is the center of that circle. Okay? Now these are the 2 points where the arc intersects 2 lines forming an angle. The length between these 2 points is called length of the arc. Length of the arc which has subtended the angle, which has covered the angle, which has formed this angle. So this angle is denoted by symbol d theta. What is this? Length of the arc. Length of the arc which is in front of this angle. It is denoted by ds, where s is a symbol of length of arc. Length of arc is denoted by s, also denoted by l. Any length can be denoted by l. Okay? D symbol is used when you know that the length is a smaller value. So ds is the length of the arc, d theta is angle, and you can see that the distance between these 2 points is radius. Think about this. Here is the circle. So this length is radius. Okay? If you understand the diagram I have drawn, then you are able to understand the definition of a plane angle. I am writing a formula to derive definition, to define this angle. D theta is ds upon r. Here is the formula of d theta. Think, what is d theta? It's an angle known as plane angle. What is ds? Length of arc. What is arc? Radius of the circle of which this arc is. Now think about the definition. D theta is given or is explained by the ratio of ds to r. This ratio is known as plane angle. Okay? Which ratio? Which ratio? Think about. Ratio of length of an arc, ratio of length of an arc of any circle to the radius of that circle is called plane angle subtended by that arc. This is the definition. I am writing the definition for you here. Ratio of length of an arc of any circle to the radius of that circle is called a plane angle formed or subtended by that arc. Subtended by that arc. Okay friends, this is the definition. Formula is in front of you, definition is there. Now the important thing is d theta is the symbol of this physical quantity. Now the question is, in which unit you will measure plane angle? You know that plane angle is measured in degrees, but in fact degree is not an SI unit. In this SI, the unit of a plane angle is radian. Okay. The other thing is, we will convert radian into degree and degrees into radian for our convenience. There is a method. But in case of SI, in our studies, we will use only SI units for numericals. So the unit of plane angle is radian, and symbol of this unit is rad. Don't forget, here is the unit of a plane angle and this is its symbol. So measure of any angle is, any plane angle is written as small r, small a, small d, that's rad. Spoken as radian, written as rad. Got it? Any problem? No. Now the last point is the second supplementary physical quantity, that is solid angle. Okay, I will give you some information about solid angle and I will give you the definition of solid angle in homework. In fact, I will explain, but you will write the definition in homework. Okay, here is supplementary physical quantity number 2, and that is solid angle. Its symbol is d omega. You know this symbol, you know this sign as ohm, George Simon Ohm, as a unit of resistance. But in this chapter, it is sign of a solid angle. Okay. Now solid angle is a 3-dimensional angle, and it can be understood in terms of a sphere with respect to a sphere instead of a circle. Look at this. In this case, we have taken a circle, we have taken an arc and radius. Ratio of an arc to the radius is a plane angle. But for a solid angle, we require a sphere. You have seen a watermelon, many times you have seen. Okay. What you see when you ask or demand a piece to test, What does the shopkeeper do at that time? It cuts the watermelon in this manner. Look at this. With a knife, it cuts the upper portion in a square form. Okay, means at the top it is a square form or a surface form, but at the end it's a point in the center of the sphere or spherical watermelon. When it takes out that piece, you see that piece because your intention is to test the watermelon. You have never seen the gap that has been formed in the watermelon. If you see that one, you need not understand solid angle. In fact, that gap produced or formed in the watermelon is known as solid angle, and it's denoted by d omega. Okay, I am trying to draw that angle. Here is a portion of that watermelon. Here is the surface area, that is either square or a rectangular portion. Okay, in this case it was only an arc, so it has only one dimension, that is length of an arc. Here in this case it is length and breadth, since it's a part of spherical surface. Part of a surface is measured as an area, that is denoted by dA. Here it was ds, length of the arc. Here it is area, part of total spherical area. Look at this. Here is the center, and a small portion of a sphere has been cut. So this small area or small part of total spherical surface is denoted by dA, and all these lines are nothing but radius of the sphere. Okay, now I will give you the formula of d omega as it was given in this case. Here is the formula: d omega equals to dA upon r square. Here is the formula for you. Now, aren't you able to define solid angle in this manner? Look at this: ratio of length of an arc. What will you use instead of a length? Instead of the word length, you will use area. Area of what? Area of a small part of a spherical surface. Here it is length of an arc of any circle. Instead of circle, you would use sphere. Instead of length, you would use area. So ratio of area of a small part of any sphere surface to the square of radius, not only radius but square of radius, is called a solid angle, subtended or covered by that surface or the portion. Okay, in short, you will write the definition and I will give you the hint. Area of a small portion of a sphere or its surface to the square of the radius of that sphere is called solid angle, denoted by d omega. And now the question is, in which unit solid angle is measured? We measured plane angle in radian. Now solid angle is measured in steradian. Okay. The unit of solid angle is Std-radian. Std-radian. Unit of plane angle is radian. Unit of solid angle is Std-radian. And Std-radian in symbol is denoted by, it is denoted by SR, Std-radian. Okay, spoken as Std-radian, written as SR, spoken as Std-radian, written as SR. Okay, any problem? I hope you will complete the definition for yourself. You will complete the entire table of SI units and 2 supplementary physical quantities. In the next lecture, I will explain you how you can convert radian into degrees and degrees into radian. We will attempt a few sums. We will practice some questions. Okay, thank you very much.